Next problem, find the finite Fourier cos transformation of f of x is equal to 1 minus x by pi whole square. Given f of x is equal to 1 minus x by pi square, so that is equation number 1. We know finite Fourier cos transformation defined in the interval 0 pi is given by fc bar of p is equal to integral 0 to pi f of x cos px dx. That is equation number 2. Using 1 into, so fc bar of p which is equal to integral 0 to pi 1 minus x by pi the whole square cos px dx. That is equation number 3. So now we are going to evaluate this integral by using Bernoulli's formula. U dv, integral u dv is equal to uv minus u dash v1 plus etc etc. We know u dash u double dash are successive differentiation of u, and v1 v2 etc are the successive integration of dv. Here u is equal to 1 minus x by pi the whole square and dv is equal to cos px dx. So u dash du by dx derivative of 1 minus x by pi the whole square with respect to x. So 2 times 1 minus x by pi into derivative of minus x by pi, that is minus 1 by pi. So which is equal to minus 2 divided by pi into 1 minus x by pi. U double dash, u derivative of u dash, so derivative of minus 2 divided by pi into 1 minus x by pi, that is equal to minus 2 divided by pi. So derivative of 1 minus x by pi, so minus 1 by pi, that is equal to 2 by pi square. Now v is equal to integral dv, so integral cos px by dx, that is equal to sin px by p. So v1 equal to integral v dx, so sin px by p dx, that is equal to 1 by p sin integral sin px dx, which is equal to minus 1 by p square cos px. Then v2 is equal to integral v1 dx, which is equal to integral minus 1 by p square cos px dx. So that is equal to minus 1 by p square sin px by p, that is equal to minus 1 by p cube sin px. So 3 implies fc bar of p which is equal to integral 0 to pi 1 minus x by pi the whole square cos px dx, which is equal to, so Bernoulli uv, so u is 1 minus x by pi the whole square, v is sin px by p, lower limit 0 upper limit pi, minus u dash is minus 2 by pi into 1 minus x by pi, and v1 minus 1 by p square cos px, so lower limit 0 upper limit pi, then plus u double dash 2 divided by pi square into v2 minus 1 by p cube sin px, lower limit 0 upper limit pi, applying upper and lower limit for each term. So 1 by minus pi by pi square sin p by p minus 1 minus 0 sin 0 by p, right, first term. Second term applying upper and lower limit, minus 2 by pi 1 minus pi by pi 1 by p square cos p pi minus 2 by pi 1 minus 0 1 by p square cos 0. Then third term minus 2 by pi square 1 by p cube sin p pi minus 2 by pi square 1 by p cube sin 0. So we know sin pi p pi is 0, sin 0 is 0. So 0 first term 0, second term 0, minus third term 0, then 2 pi pi, right, 1 by p square, right, then 0 minus 0, right, 0 0, right, because cos 0 is 1, that is why 1 by p square, minus 2 by pi 1 by p square, minus last two terms also 0. So fc bar of p is equal to 2 by pi p square. This is valued for only p greater than 0, right, not equal to 0. Definitely if it is 0 it is not exist, right, anything by 0 infinite. So if p is equal to 0, so 3 implies put p is equal to 0, fc bar of 0, right, instead of p you put 0, which is equal to integral 0 to pi 1 minus x by pi square cos 0 dx, cos 0 1, that is equal to integral 0 to pi 1 minus x by pi whole square dx. So 1 minus x by pi whole cube by 3 into 1 by minus 1 by pi, right. We know ax plus b whole power n integral ax plus b whole power n is equal to ax plus b whole power n plus 1 by n plus 1. So here instead of a you are having minus 1 by pi n plus 1 into a, right? Correct. So integral ax plus b whole power n dx is equal to ax plus b whole power n plus 1 by n plus 1 into a in the denominator, right? Coefficient of x should be, right? Here a is equal to minus 1 by pi, right? B is equal to 1. Using that formula, n is equal to 2. So you will get 1 minus x by pi by 3 whole cube, 1 minus x by pi whole cube by 3 into 1 by minus 1 by pi, lower limit 0, upper limit pi. So that is equal to minus pi by 3, 1 minus x by pi whole cube, right? Lower limit 0, upper limit pi. Now applying upper and lower limit, minus pi by 3, 1 minus pi by pi whole cube minus 1 minus 0 whole cube. So minus pi by 3, 1 minus 1 whole cube minus 1 minus 0 the whole cube. So minus pi by 3, 0 minus 1. So you will get pi by 3. So finite Fourier cos transformation of given function f of x, which is equal to pi by 3 if p is equal to 0, right? So there are two values for fc bar of p, which is equal to 2 by pi p square if p is not equal to 0, that is greater than 0, pi by 3 if p is equal to 0. Thanks.